What I do just to take you, I'll take you somewhere deep within. You know I'd die for you. Yeah, I'd die for you. Oh yeah. Close my eyes, but I can't escape this
Whoa! Alright, man. I think it was too... What?
You must be wondering how we can heat water to above 100 degrees Celsius. This is possible without the presence of bubbles. Containers, cups, and plates suitable for microwaving usually has very smooth surfaces and has no cracks. Thus, they do not enable bubbles of air to cling to their sides when the water boils. As such, there are no nucleation points, or points where water can turn into water vapor. Now you must be wondering what nucleation points are. Well, basically, nucleation points is the interface between the water surrounding the bubble and the steam inside the bubble itself. So if I were to represent nucleation points, it would be all these dots over here. I'll represent it as N for you. Additionally, for bubbles of water vapor to form, the water pressure within the bubble must be greater than the combined pressure of the ambient pressure, which is the pressure of the water itself, and surface tension. So ambient pressure would be here, surrounding the bubble. And this would be the surface tension. Now think of surface tension like the elasticity of rubber of a balloon. When blowing up a balloon, the hardest part of blowing up a balloon is the starting, where the balloon diameter is small. As the diameter of the balloon gets bigger, it gets easier to blow. Likewise, surface tension is inversely proportional to the diameter of the balloon. In this scenario, where there is a bubble just a few microns in diameter, there is a tremendous amount of surface tension. In order to overcome it, the water absorbs heat energy.
As the water continues to be heated by the microwave, the water eventually reaches temperatures above boiling point. However, the superheated water appears to be below the boiling point, but the moment the water is disturbed, the water violently flashes to steam, spraying boiling water out of the cup. This violent eruption can be triggered by adding a substance to it, such as coffee powder, or putting a spoon into the cup of superheated water, or even just moving the cup of water. This is so because the particles of coffee powder drags tiny bubbles of air, which acts as nucleation points for the water to turn into steam. Considering the water had no nucleation points to begin with, the water had absorbed an incredible amount of energy. Thus, by introducing those bubbles, the water in the container go through a massive spontaneous boiling, so to speak. Chances of superheating can increase with repeated heating and cooling cycles. For instance, when a forgotten coffee cup is reheated without being removed from a microwave oven. This is due to heating cycles progressively degassing the liquid.
A magnetron tube within the microwave oven is used to produce short electromagnetic waves known as microwaves. Microwave energy is directed into the cooking chamber where the food is placed and causes water molecules within the food to heat up through a process called dielectric heating. Water molecules are polar molecules, meaning that it has a slight charge at certain parts. As the microwave propagates through the body of water, the molecules of water align themselves according to the electromagnetic field. This movement is called dipole rotation, and it pushes, pulls, and collides with other water molecules, thus transferring energy throughout the body. The movement of these particles translates into heat energy,